So, as you can see, I'm going to talk about DataMapper 2. It's an object mapping toolkit. So, quick introduction myself. Hi, I'm Solnik. My name is actually Piotr Solnica, but everybody knows me as Solnik. I'm a software consultant. Basically, I'm a Ruby developer and JavaScript as well. I'm in the DataMapper core team. Here's my blog, my GitHub handle, and Twitter. So, before I jump into DataMapper 2, I want to talk a little bit about the patterns, Active Record and DataMapper, so that people basically understand what's the difference between the two. So, when it comes to Active Record versus DataMapper, there are some really important differences. So, let's start with Active Record. First of all, it's a very simple pattern. The basic concept is that an Active Record object represents a row in a database table. And it's designed for very, very simple use cases, because there's no separation between persistence and domain objects. This means that if your business logic is really complex, and you start mixing together persistence concerns with your domain logic, then you might end up with a big mess. So another problem with Active Record in bigger projects is that your domain is tightly coupled to the structure of your database. There's one-to-one mapping between what you have in your database and what you have in your domain. So on the other hand, we have DataMapper, and it's a completely different thing. It's quite an advanced system. It actually consists of multiple patterns like mapper, unit of work, repository, or identity map. It has, as opposed to Active Record, it has a strict separation between persistence and domain. So domain has no knowledge about persistence. And it's a huge difference. It helps when your business logic is really complex and you want to just get away from persistence concerns and focus on designing your system the way you want. So the problem here is that people usually talk about Active Record versus DataMapper, which one is better, and there is no really good answer to this question because both patterns are quite great. And it's important to understand which one you should use for your specific use case. So it's not really about which one is better, it's about both patterns and understanding when you should use which one, right? So, what went wrong with Active Record in Rails? As I said, Active Record is supposed to be simple. It's supposed to be used in simple use cases, in simple products, simple applications. But the way we've been using it is really, really, really bad, because we've been using it for everything. So, it's simple, right? Yeah. A model, right, it inherits from Active Record base. I mean, it's really simple. You just have an empty class and you get a lot of stuff for free. But if you take a look at how many methods Active Record base adds to your class, then it's quite overwhelming. Like, how come this is simple? So when you try to, well, yeah, Active Record does too much. When you try to think about what are the responsibilities of Active Record, you obviously start with persistence, and I would really love to stop here. I would really love that Active Record in Rails would take care of persistence, and that's it. Unfortunately, it also takes care of validations. And you might say, well, it's needed, right? Of course it's needed. But validations usually depend on the context. And for example, in a Rails app, your context is a web form. And it would be really better to have a form validation object rather than having all this validation logic mixed into your Active Record object. This way we could keep things separate and more clear. It also has life cycle hooks, which is a terrible thing. It also works well in small cases, small use cases, simple projects where domain is really simple, but when it grows, it ends up with a mess, always. It also has typecasting. And when you think about it, typecasting is only needed in certain use cases. For example, you get a user input from a web form, you need to coerce values into some other object types. But you don't always have to do that. an active record is like an ORM designed for a web system, right? What if you want to use it for a different thing? Then you get stuff that you don't really need. And yeah, but this is probably being removed right now, so I should probably remove it from this slide. But it was also for many, many years an active record, so it was crazy. This is, this is something that shouldn't be there. And yeah, what we do, or at least what we were doing for many years, is that we were putting even more things into Active Record. We're extending Active Record with plugins, adding even more responsibilities to those objects, ending up with projects that, for example, had 10 Active Record models with 1,000 lines of code in every object, and it was just unmaintainable, completely unmaintainable, really hard to test, very confusing, hard to change, hard to refactor. And this is what leads us to DataMapper 2, because all those experiences that we've had with Active Record made us realize that we just don't want to use Active Record. And one thing I should mention is that a current stable version of DataMapper, DataMapper 1, is actually an Active Record. So we have some DataMapper-ish functionality built in, but at its core, it's still an Active Record. So after, 4 years of trying to build a better Active Record, we just realized it will never happen. We just need to do something else. And because there's a different pattern called DataMapper, and we don't have any implementation of DataMapper in Ruby community, we are just hoping to do that. So here's a very simple diagram showing the architecture. And what's important here is that DataMapper 2 consists of multiple projects. It's not one huge monolithic library, it's actually a collection of libraries that you can already use separately, but altogether it works as a huge DataMapper system. But you have access to all those layers that I'm going to show you in a minute. So, first one is domain model. And this is where you're going to put everything. This is where you're going to put your business logic, this is where you're going to implement everything that's specific to your system. You can have any kind of object there, you don't have to inherit from anything. You just do whatever you want there. You design your system the way you want. You don't think about how it's going to be persisted. It's a detail, and you're going to take care of this later. So then you have mapper and session, and this is the layer that actually knows about the domain model. And it also knows about the repository. And the repository is basically the thing that gives you data from the database. So what's really important here is that domain model has no knowledge about mapper, session, or repository. It's just unaware that they even exist. And mapper and session knows about both domain model and repository. So when you think about domain model, if you start working on some application and you want to design it, you are not constrained to any kind of a framework or library. You can do whatever you want. So, for example, if you need a user class, a user object with some behavior, you can just do it like that. It's just a class, a Ruby class. It doesn't inherit from any special thing. It doesn't include any magical modules. It's just a plain Ruby object. And what's really great about it is that when you want to write a test for it, I use RSpec, so it's an RSpec example. You just require the user, require RSpec, write your spec, run it. It runs in like splits of a second, and you're done. It has no dependencies. You don't have to load any frameworks, libraries, or do any kind of magical thing in order to run your test. You just require your file and run it. So you can put a lot of stuff in your domain layer. As I said, you can put validations there, some serialization stuff, just whatever you want, whatever your application needs. But obviously we need persistence, right? We need a way of persisting stuff so we can get it back later in the same state as it was before. So how do we do that? So how do we retrieve data from the database and convert this data, this raw data, into your objects, into your domain objects? Well, this is where the mapper kicks in. And I should mention probably that DataMapper hasn't been released yet, but we are working really hard on it. And I'm suspecting that it's going to be released like next month, so it's pretty cool. So let's take a look again at our domain object. This is the user class that I showed you before. So, as I said, it doesn't include anything special, it doesn't inherit from anything, and we want to persist it. Well, let's assume it's already persisted and we want to retrieve it from the database. So how do we do that? In DataMapper, you just implement a mapper class. And this is a very explicit way of doing it, but you can do it. As I said, you have access to all layers in the DataMapper 2 stack. So there's no magic, there are no funky things going on in the background that you don't understand. You have access to everything. So if you want to implement the mapper yourself and configure it yourself, you can just do it. So it actually inherits from a special class. So the user mapper inherits from relation base, and we say, okay mapper, so I want you to load the user objects. And those user objects live in a table called users. And this table is in a database called Postgres. And the user has 3 attributes, okay? So it has an ID, which is an integer. And it's a key in the database, a primary key, so we configure it here. It also has a name, which is a string. But in the database, the field is called username. So when you retrieve it, take the value from the username field and turn it into a name attribute. And it also has an H attribute, which is an integer, and it's a one-to-one mapping, so we don't do anything special here. But as I said, this is a very explicit example. This is what you can do, and sometimes probably you will want to do some fine-tuning and build your custom mappers with some really customized, for example, relation queries or whatever. But for convenience, we obviously want to provide a really easy-to-use API. So, actually 2 days ago, I added this. So here's our user, and it actually does include some magic, but it's not as bad as an active record base. It's a very simple extension that basically allows you to define your model, define what attributes your model has. So we do the same as we did in the plain Ruby object. We define 3 attributes: ID, name, and ID is an integer, the name is a string, and H is integer as well. And then we can use DataMapper to generate a mapper for us. And we only specify things that are not default. So we say the key is called ID, and name is mapped to username. So those are 2 special cases. And we obviously can add some conventions later, like that an active record ID is always a primary key. We can do that if people want, but you always have a very explicit way of defining things, of configuring things. So you always have access to basically everything, which is really nice. So once we have the mapper, we can access instance of this mapper with the square bracket method in the DataMapper module. And as you can see, this is for examples of running a query. And it's really similar to what you know from Active Record or DataMapper 1 or other ORMs in Ruby. It's really not complicated, it's still easy to use, it's still something that you basically know from other systems. So here we grab all users, or grab all users and order them by age, or get one user that has a name Jane, or all users with age equals 18. So this is really very similar to what we know from other systems. But what about relationships? Obviously we support relationships. DataMapper 2 will support everything that's in relational databases. So here we have an address with some attributes and the same user object that I showed you before, but it has an address, right? So we say, okay, this user has an attribute and it's an address. And what's important here is that we don't configure some relationship in the database. We just say, okay, here's my domain object, it has some attributes, and one of its attributes is an address. And it's an object which type is address, and that's it. We just specify it the same way as we specify other attributes. So there's no special thing going on here. So to configure the relationship, we use the mapper. So as I said, domain object has no knowledge about persistence, so we don't want to configure a relationship in a domain object, we do it in the mapper. So we generate a mapper for the address, we generate mapper for the user, and then we say, okay, so the user has a one-to-one relationship with address. And when we do that, everything that's specific to this relationship is being set up in the relationship. So the mapper has access to all the information it needs, like that there's a foreign key in the address object, and it's called user ID by default, for example. So this is the main difference between Active Record, one of the main differences between Active Record and DataMapper, that you configure persistence-related stuff in the mapping layer. You don't have any persistence details in your domain object. So the nice thing about it is that when you go back, let's say we use relational database, and then we want to switch to something else. If we want to switch to MongoDB, we will just reconfigure the mapper. I can't show you this now because it's not supported yet, but it will be. And even though it's not a common case to switch databases, I've heard this argument a lot, like, who does that? Well, sometimes people do that. I did that. So it happens, and when it happens, it's usually a pain if you use something like Active Record, which is so strictly, tightly coupled to the structure of your database. Then you have a really big problem, and it's really hard to change it. So So the next thing is, how do you load our user object with address? And it's really similar to what we have in Active Record or DataMapper 1. We just say, okay, load those users, but include addresses, and it's just gonna work. So again, it's still simple. It's still a simple API. There's nothing special that you need to do. It just works. So what about an equivalent of has many in Active Record? We also have that. And again, we have two domain objects, an order and user, and we say, okay, so the user has an attribute called orders, and it's an array of orders. There's no specific information about how it's associated, because we don't just define an attribute here. We don't care if it's persisted somewhere, we don't care how it's configured, how it's being fetched from the database, what foreign keys are involved here, if there are foreign keys. It just doesn't matter. We just want an attribute which is an array of orders, and that's what we do in the domain object. So then we configure the mappers, just like in the previous example, and we say, okay, so the user has a one-to-many relationship, and again, all the details of the persistent stuff are defined here in the mapper. You don't have them in your domain model. Whoops. Yeah, and at the bottom we have how to load it the same way as we did with the address. So still, it's simple. So mapper is about reading data from your database, or any data source actually. So how do we make changes to our database? And this is where the session kicks in. And this is a completely work in progress thing. But again, we're gonna finish it eventually. So I'm gonna show you some examples. It's going to look more or less like on the slides, but I just want to show you the concept, the idea behind the session, so you understand the difference between how you approach making changes to your database when using Active Record as opposed to DataMapper. So here's the session. Basically, every time you want to make changes to your database, you open a session, you start a session. And the session works like a transaction by default. The default behavior of the session is a transactional behavior. So you don't have an ad hoc approach to making changes to your database, like in Active Record, for example. When you think about it, in Active Record, you have like 10 methods that make changes to your database. You can save, you can update attributes, you can call update on the model, you can just do a lot of method calls, and you just need to know which method actually make changes to your database. So when you have like a huge chunk of code in a array sub, for example, that you haven't written, for example, and you want to understand what it does, you need to be aware that, okay, so here the user was saved, here something was deleted, here something was updated, oh shit, there's an exception, blah, 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 blah. Where in DataMapper you have the session, and it works like a transaction by default. So, how it works? Within the session, we created a new user, and we say, okay, session, is the user persisted? And this is another difference. In active record, you ask the object if it was persisted. Like in active record, it's called, I believe, new record, right, or something like that, or persisted as well. So the object itself in active record is aware that it can be persisted, and it's aware if it was persisted or not. In DataMapper, your domain object has no knowledge about persistence, as I said. So if you want to get information about the state of your objects, in the context of the database, whether or not something was saved, you ask the session. You can't ask your domain object. You need to ask the session. And the session, it includes something called identity map. So every time something was loaded from the database, it gets stored in the identity map of the session. So when something is new, the session just performs a lookup in the identity map. And if the object is not there, then it hasn't been persisted. Easy. So then we say, okay, queue the user to be persisted. So when you call session.insert, it just puts the user to the queue of all the commands that it needs to perform later. It doesn't insert the user right now. It just waits for you until you hit the commit button, right? So when you do that, the session will take its query and go through all the commands that it needs to perform, and it will just do it. So this is a trivial example. Another one is how you fetch data from the database. So as you probably remember, I showed you some examples how you can load data with a mapper instance. So the difference here is that we use session. And the session actually under the hood will use the mapper. So it will use the mapper to fetch the object from the database, but then it will do its special thing, which is storing that user in its identity map, as well as saving its original state. So when we change, fetch the user and track it. Track it means track if it was changed or not. So when we change the age of this user, and we ask the session, was the user changed? It was, it was changed because the original state that I have is different from what we have now in the memory. So it's easy. And again, well, I forgot to add save. So yeah, there should be another line saying session.save user. So yeah, at the end we call commit, and the session actually will update the user in the database. And again, it waits until you call the commit method. It doesn't do anything in the database until you call the commit. So both examples were really easy, concerning only one object. So here's an example with two objects. These are the objects that I showed you before in the mapper section. And here we have a user and its address. So we create both objects and we say assign the address to the user. So right now the user has its attributes as well as its address attribute. And then we say, okay, queue the user to be persisted. And again, the session still waits until you hit the commit. So we do that. And now the session will write both objects to the database. And this is, again, another huge difference between Active Record and DataMapper, because in DataMapper, resolving dependencies between all the commands that need to be executed in the database, all those commands and dependencies between them are being handled by the session. So again, in Active Record, if you create a user with this address, the actual user has to figure out that, okay, I have an association called user, and I actually have an address, and I actually have an address object, so I need to save myself, get my ID, and then I need to save the address, but if the address fails, then oh boy, yeah, we have a problem. So in DataMapper, this is always a transaction. By default, you will be able to turn it off, but it's not recommended. So in DataMapper, the session is responsible for resolving all those dependencies. And it has all the details it needs to in order to do that. It has access to mappers, it has access to all the data that's related to persistence. So when the session looks at the user and its address, it knows that it's an association, that there's a foreign key that needs to be set, that it needs to save the user first, gets its ID, assign it to the address, then save the address. But if the address fails to save, then we need to revert everything. We need to roll back. And it will work out like that out of the box. So you get transactional behavior out of the box. Okay, what's the time? What? Should I speed up? No? Almost done. Okay. Should speed up then. Okay, so last thing is repository. I mentioned that in DataMapper 2 we have those libraries that DataMapper 2 consists of multiple libraries, and all those libraries are decoupled and you can use them separately. And I also mentioned that everything has a nice API, a nice interface. So a repository is actually this. Veritas is a powerful relational algebra library, and it was created by Dan Kapp in 2010 actually. He started working on Veritas in 2010. So after 2 years, Veritas supports all relational operations. And also, what's interesting is that all those operations can be run in memory, which can be confusing to somebody, but all it means is that Veritas works like a database. So we have a database written in Ruby right now. It can work like a relational database, so if you want to use some, for example, remote API, remote JSON API, which you can just use to fetch data, but you want to work with this data, just like if it was fetched from a relational database, you can do that because Veritas provides you the same interface as if you were using a relational database, which is really cool. So it can be extended to support any kind of a data store. This is one of the goals of DataMapper 1, which was almost impossible to achieve. We added various adapters in DataMapper 1, but we didn't have a good abstraction like Veritas, which would provide support for operations in memory that are not supported by a given backend. So this is what we have in DataMapper 2. That's why we can achieve this goal in DataMapper 2. And you can use Veritas to work with multiple databases at once. So you're not constrained to one database. So I said that you can perform operations in memory. So how do you do that? Here's the user that you're familiar with. We create the mapper for this model. And when you take a look at the mapper, you will see that it has a relation. And this relation is just a Veritas gateway relation. And a gateway relation is just a relation that knows how to talk to a database. And that's it. So it's like a special case of a special type of a relation. So when you take a look at the header of this relation, you will see the same attributes as we defined in the mapper. So we have ID, integer, username, string, age, integer. But here we don't have any mapping, obviously, because this is row header that corresponds to the actual table in the database. So this is simple. And we can use this relation to build an in-memory relation. So we use the same header and we give it some data. So we give it 2 users. And then we can, for example, call a restrict method, which performs a restriction operation. And it basically restricts the collection of users to the ones that have age greater than 18. And still, this is still simple. This is still a simple API, and you can use it. If you want, you can use it. If you must, you can use it. And the mapper works in a very simple way. It just uses its relation to perform various operations, relational operations. So if you call find, for example, on the mapper, under the hood, it will just use its relation and perform a restriction, that's it. But if you find the mapper fail at doing some super complex query, you can fall back to the relation and use its lower level API to do something that the mapper doesn't support. So, as I said, you have access to all the layers, and everything has a public, nice, stable interface. So, I said that Veritas supports all operations in memory, running all operations in memory. So here we create two relations in memory. We use both mappers from previous examples, so we have a user relation and an address relation. And we can just join it in memory. So the rename part is required to perform a natural join, and this is what the mapper does under the hood, but you don't have to be concerned about it if you use the mapper. But if you need to perform some super crazy complex query, you can use relation directly. So we created this joint relation in memory. So when we perform a restriction, it will also run in memory because we have data in memory. So why do we need that? As I said, we want to support any kind of a data store. In order to do that, we need something that would give us the same features as relational databases have. So if you have data from, I don't know, an XML file, you don't have, obviously, an XML file doesn't support joins, right? So you can use Veritas to perform all those operations in memory, and it's quite handy. So feel free to use it already, because Veritas has been released, it's stable, and its version is below 1, but it's stable in a way that it works. So yeah, and thank you, that's it.